Hello everyone. So for the first question, there are 6 basic functions. So I'm going to name them. The first one, as you see, if you think of this to be opposite of or reciprocal of a function, this was the original, that this is the reciprocal, because if you see that this has been flipped. So what is this one? What is the function before reciprocal? That's cosine. So this is a function of reciprocal of cosine, which is secant x. So y equal to secant x. So the next one, it's just, so all 6 of them are the basics without any transformation. So it's y equal to sine x, and if you remember, every time teaching every basic, I ask you to know the original model. Part C is the original model for cosine x, starting from 1, going down to -1 and returning to 1 for 1 period. All of these are for 2 periods. D is y equal to tan x, knowing that pi over 2 and negative pi over 2 are the asymptotes, vertical asymptotes, passing through 0, 0. And then tan of pi over 4 is 1. Tan of negative pi over 4 is -1. So it's y equal to tan. And then again, if you think of this one as a reciprocal of a function, where you have zeros of this function is the asymptotes of the original. So this function is sine. This is reciprocal of that, so it's cosecant x. And then getting to the last, not the least, y is equal to, for this one, the asymptote is 0 and asymptote is pi. It's cotan x, and then if you think cotan of pi over 2 is cosine of pi over 2 over sine of pi over 2, which is 0, it's right there. Cotan of pi over 4 is 1, and then cotan of, this is 3 pi over 4, is -1. So it's cotan x. Okay, you want to find an equation for these graphs? So this looks like the behavior of a cosine. If you bring it 1 down, you would see 1 down here, 1 down here. If this was 1 down, then it would have looked like cosine more. The only thing was with the period, that is 4 pi. So we know to find the period of cosine x, so period of that is 2 pi. Period of, so we said we're gonna divide period of cosine of, let's say, bx is 2 pi over b. Now you want to know, what is this b? Definitely is not cosine x, because it's 4 pi, it's not 2 pi, is what you have here. So basically the period 2 pi over b is equal to 4 pi, because you clearly see that the period is 4 pi. So in order to solve for b, you can cross multiply. So b times 4 pi is equal to 2 pi. You divide both sides by 4 pi to isolate b, so you get 1/2. So here is the equation, y equal to cosine 1/2 x. So, and you know that the function has been shifted up from the original to get to the new one. So if this was cosine, it's been +1 to give you the one that has been drawn. Okay, next one. The behavior is very close to cotan. If you compare this with 1F, you see that this is very close, same period. So you know that the behavior, it's going to be like cotan X. But it seems that it's flipped because cotan is like that, but this been exactly flipped. So it's negative cotan. And then what else, you know? It's not been shifted up or down, but you see that the outcome of pi over 4 is negative 1/2 instead of positive 1. And then the outcome of negative 3 pi over 4 is 1/2 compared to negative 1. So if you look at here, these are 1 and negative 1, and these are half of it. So that's why we're going to have y equal to negative 1/2 cotan. So you knew that it's been flipped, so that's the negative. You know the outputs are half of the original. If those are 1 and negative 1, this one is negative 1/2 and positive 1/2. Okay. Next question. So what is the domain of cosine function? Domain, you can give anything you want to cosine function to sine function. So domain of sine and cosine is negative infinity to infinity. The range of sine is from negative 1 all the way to positive 1. Because if you think of the graph, you can go anywhere, but nothing beyond 1 and nothing below negative 1. So that's why sine function is bounded between negative 1 to 1. So not lower than this and not higher than 1. Okay, what is the least positive value where tangent is undefined? Even if you look at the graph, tan is undefined as you're moving. If you look at 1D, tan is undefined as pi over 2. So that's the first undefined of positive. The first undefined of negative, if you look at 1D, is negative pi over 2. But since they said positive, and as you go on, there are more and more of undefined. Basically, whenever the denominator, whenever the sign of x is 0, tan is undefined. So the first tan, for the first value of x that tan is undefined is when x is equal to pi over 2. Okay. What is the range of secant function? If you think of secant function as of 1a, the range of secant function is anything above 1, so 1 and above, negative 1 and below. So range means outcome. So if you look at 1a up here, everything above 1 and everything below negative 1. So it's going to be negative infinity up to negative 1 union with 1 all the way to positive infinity. To answer this question, I start by graphing this one. First, you put inside the parentheses between one period. You want to graph it over one period, so you're going to put it between 0 to 2 pi. So you would say 2x plus pi over 2 between 0 to 2 pi. Then you subtract pi over 2 from both sides, or all three sides. That cancels, so you have 2x in between negative pi over 2 and 2 pi minus pi over 2. You get a common denominator. You multiply top and bottom by 2. It's 4 pi minus pi is 3 pi over 2. Then you're going to divide every side by 2, or in another word, you multiply it by 1/2. So you can think of multiply by 1/2 because that's the same thing, canceling. So multiply by 1/2, multiply by 1/2. So x is between negative pi over 4 to 3 pi over 4. Okay, so you start graphing. If this is negative pi over 4, and this is pi over 4, 2 pi over 4, which is the same thing as pi over 2, and 3 pi over 4. In this case, the increments came out. So they are already 4 pieces here, 1, 2, 3, 4. If these were not coming out as easy, you would have say, what is half of negative pi over 4 and 3 pi over 4? So to find half of that means finding this point right here, the exact midpoint. You add them, it's 2 pi over 4 divided by 2 is the same thing as multiplying by 1/2. So it's the same thing as pi over 4. Then you would have get this point. Then half of negative pi over 4 and pi over 4, same thing. You add them, you divide it by 2, you get 0. Half of pi over 4, 3 pi over 4, you add them, you divide it by 2, you get this point. Okay, so let's say this is negative 1 and this is 1. The amplitude of this sine function is 6. So if you want to think about it, instead of 1, let me just mark it as 6, because if I want to think about it, so let's say it's 6 right here. And let's say it's 9 right there, 3 right here, negative 3 right here, negative 6 right there, negative 9 right there, and so on and so forth. So if I was thinking of just sine, not negative sign, then that would have been my graph. So you start from 0, behavior of sine, you go up, you go down in the second increment back to 0, and the third increment you are at the lowest point and back to 0. That's regular sine. This dotted point is regular 6. Sorry, got erased. So that would have been, this would have been sine graph, which in this case it's going to be 6 sine 2x plus pi over 2. We already did all the shifting. But now you're looking for negative 6, so you're flipping the function. So that's the function if you're flipping. So you're exactly flipping the function. So then this one would be negative 6 sine 2x plus pi over 2. But your graph, you need to say at 3, so you are moving every point 3 up. So this point will go up here. This point will go up in here. This point will go up 3 here. This point will go up 3 at 9, up 3 right here. So the graph would be the one that I'm just doing as a solid line as the final graph. So you are basically moving the graph 3 up from every point. So then what you have as the solid line is the final graph of this function. So now to answer these questions, what is the period? Period is always 2 pi over b. In this case, b is 2, so it's pi. And if you see between negative pi over 4 to 3 pi over 4, there is a distance of pi. What is the amplitude? Amplitude is what